To find the oblique asymptotes, we have a couple of steps to follow. Again, we're going to find the degree of the numerator and the degree of the denominator. If the function is improper, and if the degree of the numerator is 1 more than the degree of the denominator, then we have an oblique asymptote. So think about that. The function is improper, and the degree of the numerator is 1 more than the degree of the denominator. Then we have an oblique asymptote. And we're going to use long division, all the way back to week 1, to find the equation for our oblique asymptote. Before we practice finding it, let's first identify whether or not functions even have an oblique asymptote. We'll do the first two together. We see the degree of the numerator and the degree of the denominator. This is improper, but it's equal. Will it have an oblique asymptote? No. What about the second example? We see the degree of the numerator and the degree of the denominator. This is improper, but the degree of the numerator is not 1 more. So again, no, there will not be an oblique asymptote. Determine whether or not there will be an oblique asymptote for the remaining questions. For the R of X, we see that the degree of the numerator is 1 more. So yes, there will be an oblique asymptote. The H of X, the degree of the numerator is equal to the degree of the denominator. No asymptote, no oblique asymptote. For both G of X and F of X, the degree of the numerator is 1 more. So these will both have oblique asymptotes. In the next lecture, we're going to look at how to find the oblique asymptote.